Hi guys, hope you're having a great day. Today we're going to look at 3.4, which is sine and cosine function graphs. So now we're kind of taking the transition from just looking at like the values on the unit circle to actually graphing these functions. So you saw in Math 3, hopefully, that they're going to end up looking like a wave. That's that periodic idea. They're going to go on forever and ever and ever, and we can use the unit circle to help us find those values. So just a few kind of vocabulary at the top. A sine curve is just the graph. Sine of theta, just make sure, remember this is not 0, that's theta. And that's just the y coordinate because remember sine is the y. So I'm going to go ahead, look at just basic sine of x. I would recommend you pause it real quick and try to fill out these values yourself from the unit circle. Okay, so hopefully you paused it and you tried it yourself. Square root of 3 over 2, 1/2, 0. Negative 1/2, negative square root of 3 over 2, negative 1, negative square root of 3 over 2, negative 1/2, and 0. Okay. All right, so first question says, state the intervals of x where the y values are increasing. Okay, that means that they are getting bigger. So I can see from here to here, I'm getting bigger, and then I go back down. And I'm getting smaller, and then I'm getting smaller and smaller and smaller, and then from here to here, I'm getting bigger again. So that would be from 0 to pi over 2, and then from 3 pi over 2 to 2 pi. Okay, so then when they're decreasing would be from pi over 2 to 3 pi over 2. Okay, that would be this section right here. Remember, we use parentheses because at those turning points, those maxes and mins, they're not necessarily increasing or decreasing. So then state the maximum points and the minimum points. Well, there is an absolute max of 1 at x equals pi over 2. Hopefully that notation looks familiar back from unit 1. And then an absolute minimum of negative 1 at x equals 3 pi over 2. Okay, so let's look what this looks like on a graph. It's going to look something like this. One thing to note here is the y-intercept is at 0, 0, so it starts at the origin for my just parent sine of x function. And then it'll go up and then come back down, and then it'll keep going forever to the left and to the right. So if it keeps going forever to the left and the right, that means that domain is negative infinity to infinity. The range of my parent function is negative 1 to 1. I'll talk about in a minute. Well, what if I were to change some things? The amplitude is the absolute value of a, which is just the number in the front. Amplitude is always positive. So even if there's a negative, if it's like -4, well, the negative just reflects it. The period, our standard period of a sine of x function is 2 pi because that's a full circle. But if I have a number in the front, it's going to be 2 pi over the absolute value of b, where b is the number in front of x. And then my key points when I go to plot these are going to be your intercepts and your extrema, meaning your maxes and your mins. Okay. All right, so it says use the 5 key points of the parent function to graph y equals 2 sine of x. Now, as you get to do more and more of these, you may get more comfortable with kind of doing the transformations without having to make a table, but you can always go back if you were trying to graph or you're trying to do a multiple choice question and identify the graph or something like that. You can always make a table and substitute in or plug in values for x. So 2 sine of 0. So that says sine of 0 and then multiply it by 2. Well, that would still be 0. 2 sine of pi over 2. 2 times 1 is 2. 2 sine of pi, 2 times 0. 2 sine of 3 pi over 2. 2 times negative 1. And then 2 sine of 2 pi is just 0. So I'm still going to start at 0, 0. At pi over 2, though, I'm going to go up to 2. At pi, then I'm going to go back to 0. That's an intercept. At 3 pi over 2, I'm at negative 2. And at 2 pi, I'm at 0. So it looks something like this, just for the positive portion. So notice that this changed my range. So the range of this one would be negative 2 to 2. And I get that from the amplitude. Okay. Now, it could still change. Like, let's say if I had like a -4 on the end, that would go down 4. That would change by shifting it down 4 for each of my y values. Okay, we'll get there. All right, let's do one more example. The period of this one was still 2 pi because it took 2 pi to get back to the original value. This one, the amplitude of this is the absolute value of the a, so that would be 3. The period would be 2 pi over b, which in this case is 2, which gives me pi. So if I was to ask you the amplitude and the period, that would be 3 and pi. So let's plug each of these values in. So negative 3 sine of 2 times 0 would just be 0. Negative 3 sine of 2 times pi over 4 is pi over 2. Okay. Negative 3 sine pi over 2 times 2 is pi. So negative 1, that would be 0. Negative 3 sine of 3 pi over 2 would give me positive 3. Notice that each of these y values, I'm taking whatever the x is and multiplying it by 2. That's how I'm getting the number in parentheses. And then 2 pi would be 0. So I get something that looks like this. Pi over 4 is negative 3, 0, positive 3. So notice because this one was negative, my sine function normally starts at the origin and goes up, but because of this negative, this one starts at the origin and goes down. And then my period, in order for it to get back to the same place and traveling the same direction, that has a period of pi. Okay. So let's now do the same thing. We're going to look at cosine this time, but same idea. I recommend that you pause it right now and try and fill in this table of values for cosine. Okay. So the intervals of x where the y values are increasing. So I can see that's all decreasing. And then from here, so from pi to 2 pi is going to be where they are increasing. And that means, therefore, that from 0 to pi, we are decreasing. We can say that there's an absolute max of 1 at x equals 0. You could also say 2 pi, since technically both of these are included in the interval. A lot of times you'll see it written as 0 and then 2 pi in parentheses, meaning not including that point. And then an absolute min of negative 1 at x equals pi. Okay. So cosine graph looks a little bit different. Notice that the y-intercept here is 1, not 0. It doesn't start at the origin. So on my graph, it's going to start up at the maximum and then go down and go back up. All of these properties, though, domain, amplitude, range, period, and key points, are all the exact same that you see in a sine function. So I'm not going to rewrite them again, although you could. But all of those properties are the exact same as a sine function. Okay. So let's do one of the cosine graphs. I want to go to example 10 because I skipped over that type of problem in sine. So on this one, we would say the amplitude is 3 because that's the number in the front. Absolute value, amplitude is always positive. The period of this, there's no number in front of x, so the period's just 2 pi. And then the midline here is shifted. So the midline is going to be y equals negative 2. And I see that on the end because it's gone down 2. All right, so then I can plug in each of these values. So 3 times cosine of 0 is 1. So 3 times 1 is 3 minus 2 gives me 1. 3 times cosine of pi over 2, well, that's going to be 0 minus 2 is negative 2. Okay, 3 times cosine of pi is negative 1, so negative 3 minus 2 gives me negative 2. And then we have 3 times cosine of 2 pi. That's going to be back to where I started because the period is 2 pi. So I can plot these. So 0, we're at 1. Pi over 2, negative 2. At pi, we're at negative 5. Hopefully you're seeing as we're doing this why it's so important to know your unit circle and know your unit circle quickly. Okay. So it looks something like this. Notice my period is 2 pi. My midline here we said was y equals -2, and you can see that divides the graph in half. And if I was looking at this visually, the amplitude would be from -2 to 1, which is 3. And again, if I was going to talk about the range of this, it would be -5 to 1. Okay. One way to think about that is the range of 3 cosine of x is -3 to 3. And then if I shift it down 2, I'm essentially minusing 2 from each of those. Okay. So that's graphing our parent functions, sine and cosine, and a few transformations. We'll add on some more like shifting left and right as we go on. But that kind of takes you through a little bit of 3.4. Have a great day.